Yeah, it's got a, and once I write it, it'll look super familiar. Distance equals rate times time. Does that look familiar? Please tell me yes. It should. Okay. Okay, distance equals rate times time. If you don't remember that. Okay. If you don't remember. That's not how you spell don't. Okay, if you don't remember, in this case, I'm going to use a bit of a unit analysis. Because it says we want to find his average speed to the nearest, what do they want it in? 100th of a meter per second, right? Doesn't that look like meter per second, right? Meter per second. I'm going to create a verbal model. This is a verbal model. Meter per second is going to equal his speed, right? Correct? Because they give me my meter. I want my speed in meters per second. And isn't that how I would write meters per second? What is this symbol? What is this symbol right in there? What is that guy right there? That line right there. Division. That's division, isn't that? That's a division symbol. So I'm going to take my meters, divide it by my seconds, and that's going to equal my speed. And I got all of that from the actual words they gave me, because they said meter per second. So I wrote meter per second. That's going to equal his speed. So now I just fill in the information. Do I know the meters he ran?
Yes.
Sure I do. That's his distance. He ran 200 meters, right? Per, how many seconds did it take him? 19.32 seconds. That's going to equal his speed. So there, do I have an equation? I'm going to use a variable for speed. What should I use? P. Okay. But since I used a P, I have to say over here that P is equal to his speed. This little step right here is what we call defining the variable. This is us defining the variable. When we use a variable, when it comes to a word problem, we need to tell the reader, what is my variable standing for? In this case, my variable is standing for his speed. Okay. So now I know what to do, right? Don't I? Yes. Take 200 meters, divide it by 19.32 seconds. Does anyone know what that is off the top of their head? Okay. It says to the nearest hundredth. So let's give me like 4 decimal places. It's 10.3519. Okay. So now I need to the nearest hundredth. So let's look here. This is ones place, right? Sorry, tens place, ones place. What's the one right after the decimal? Tenths. This one is the hundredths. So I have to look behind the hundredths. It's a thousandths, and it's a 1. So is that going to round this thing up or down? Down. So it would stay a 5, 10.35. So my answer, and since it's an approximate, I would say his speed is approximately 10.35 units meters per second. Are you guys familiar with the approximately symbol? It's a wavy equal sign. Oh, that stupid created by Desartes down there at the bottom. Okay. All right, next one. Was the next one spearfish? Talking about spearfish, South Dakota? Yeah. Okay, and what's interesting is, guess what? This one is exactly from your textbook. Sorry. So they actually talk about spearfish, South Dakota in your textbook. Because I believe spearfish does hold the record for the biggest temperature difference in a single hour period or something.
It's probably this.
Yeah, it is. Okay, so on January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees at 9 a.m. to -4 degrees at 9:27 a.m. How many degrees did the temperature fall? So it was almost 60 degrees at 9 o'clock. In less than a half hour, it was -4 degrees outside. Brr. Okay, so how many degrees did the temperature fall? So our strategies, if we go back to our strategies, and look at a way to do this, I think I might do a number line. I think this one might be a good number line problem. But I think I'm going to draw my number line up and down. Why would I choose to draw it up and down? Because the temperature's dropping, and thermometers a lot of times are up and down like that. So here at 9 a.m., what was the temperature? 54 degrees. So I'm going to mark here 54 degrees. Okay. Down here at 9:27 a.m., that's degrees Fahrenheit. At 9:27 a.m., it was down here to -4 degrees Fahrenheit. Okay. So since this is a number line, I should probably put a 0 on it. Where would my 0 be? Where would I put my 0? Smack dab in the middle?
No.
No.
To the 4.
Yeah, it's going to be like right here next to the 4, right? Because that one's 54, so my 0 is going to be somewhere right around there, right? Approximately. Okay. So if my temperature's dropping, so here I dropped to 0, how far down did I go?
54 degrees.
I went down 54 degrees, right, to get to 0. But I didn't stop there, I kept going down. How much farther did I go down?
4.
I went down another 4 degrees. So in total, how far down did I go?
-58 degrees.
I went down -58 degrees. And I'm using a negative here to denote that the temperature went down. Is this the only way of solving this problem? No. Okay. Sometimes I could set up an equation and subtract them. Use a different color for just a different method. A different way of doing it. Okay. I could take the -4 and subtract the 54. What do I end up getting? -58 degrees. Okay. So there's writing an equation for it. Okay. Any questions on that one? No? All right. We'll do one more. We're not going to finish this lesson today, obviously. Okay. So this was from section 1-2. It says use the table to find the number of miles x. So they even defined the variable here. X is the number of miles that you need to bike on Friday so that the mean number of miles biked per day is 5. Ooh. So understand the problem. So first we need to understand the problem. What's going on here? What are we trying to find? Trying to find x, which what is x? Find number of miles on Friday. Basically this guy right here, right? That x in that table, that's our missing piece. The things that we know is we know the number of miles he biked Monday, Tuesday, Wednesday, and Thursday. Wednesday must have been a lazy day, huh? Didn't go nowhere. Okay, and what else? We know we want the mean. Holy moly, what does mean mean? Mean. What does mean mean? Okay. That's Abby, you said what? That's average? How is the average different from the mean? Average, mean. Is there a difference? Average and mean are the same thing. So here we're looking for the average. Yep, and Shelby nailed it on the head here. To find the average, you add them all up and divide by how many there are, right? So I'm going to do that. I'm going to add them all up and divide by how many there are. So I would add them up. So What do we go? 3.5. Sorry, I'm going to use black, like red. So we add, so we got 3.5 plus 5.5 plus 0 plus 5 plus what? What do we use for Friday? X. Oh no. And divide by how many there are. So I'm actually going to show that division. Divide that whole thing. By what? How many? 5. Because there's 5 days, right? Because there are 5 days. Because there are 5 days. And so what should this equal when it's all said and done? No, what do I want the mean to be? 5. So now, do I have an equation? I have 3.5 plus 5.5 plus 0 plus 5 plus x, all divided by 5. And when it's all done, I want it to equal 5, right? Okay. So what can I do first?
Add them all up.
Okay, I can add everything but the x, right? I can add the 3.5, the 5.5, the 0, and the 5. What do I get when I add those? 14. So I'd have 14 plus x divided by 5 equals 5. So what do I do at this point?
Divide by 5.
It's already divided by 5. Yeah, I have to undo that divide by 5. How do I undo the divide by 5? Multiply both sides by 5. So 5 divided by 5 is 1. So I'm left with 14 plus x equals 25. So here I'm solving an equation, right? Using an equation.
And then would you divide by 14?
Because it's 14 multiplied by x.
Oh yeah, that's right.
Subtract the 14. So 14 plus x minus 14 equals 25 minus 14. X equals 25 minus 14 is 11. Oh, you got to bike a lot on Friday. Huh? So I need to answer, how many miles should you bike on Friday? 11 miles on Friday. So now look back. Did I answer the question?
Yes.
Did I answer the entire question? Use a table to find the number of miles X you need to bike on Friday. So we need to bike 11 miles on Friday. Does it make sense? Yes. Okay.